Okay, it's time for our second lesson of block. So this is on 3.4, which is properties of log functions. So we have it right here, 3.4, properties of logs. So, okay, so if we let B, R, and S be positive real numbers, with B not equal to 1, and C can be any real number, then we have these three rules. First one is called the product rule. So the product rule says that if you have the log base B of R times S, so the product of two numbers, that's actually equal to log base B of R plus log base B of X. So in one log, they're multiplied together, or you can split that up to two logs and have them added. Then we have the quotient rule of logs. Okay, and it says if you have the log base B of R divided by S, okay, so it's in one log, R divided by S, that's the same thing as log base B of R minus log base B of S. So you can either have them in one log divided or in two logs subtracted from each other. And the last one we have is called the power rule of logs. And it says that if you have the log base B of R to the C power, okay, so you're taking the log of R to the C. That's actually the same thing as C times log base B of R. So you can actually move your exponent to the front of the log. Kind of weird, but it does work. So using these three properties, we can take like these condensed logs, we can expand them out to multiple separate logs, or we can go the other way. We can take a lot of separate logs and we can condense them down into one log. So that's kind of what we're going to be doing. We're going to be going both ways. So for our first example, we're going to expand the logarithm using these three properties. Okay, expand the logarithm. So A is just the log of 8x. Okay, so notice here I just have two numbers multiplied together, so I can use this product rule. I can separate those and add. So it's the same thing as the log of 8 plus the log of x. And that's all we're looking for the answer, so you would be done there. Okay, so if I have, for B, let's try the log of 2x over y. Okay, so notice in the top I have 2 times x and then it's divided by y. So when we expand this out, I'm going to separate every little part, the 2, the x, and the y. So I have log 2. I'm going to do plus log x since they were multiplied together, so they get added. That's the product rule. And then minus log y since it was divided. So it gets subtracted because it was divided in the combined log. So we have expanded it out. Okay, for this next one, I'm going to do natural log of x squared y cubed. And these log properties work no matter what the base is. So it works the same whether it's log or natural log or log base 3 or log base 5. It doesn't matter. Okay, so I have x squared times y cubed. So I'm going to use the product rule. And I'm going to rewrite that as natural log x squared plus natural log y cubed. But I'm not done. When I have something fully expanded, I want it to look like these. So I don't want there to be an exponent anymore. So I'm going to take this 2, I'm going to move it to the front and take this 3 and move it to the front here. That's using the power rule. So our final answer here would be 2 natural log x plus 3 natural log y. Okay. Let's try a couple more. So D, I have the log of the cube root of x over y. So if the x and the y are both in the cube root, that means I'm taking the cube root of both of those. So when I expand this, I'm going to do the log of the cube root of x minus the log of the cube root of y. And I'm subtracting because these were divided. But just like how I don't want an exponent in my final answer, I also don't want a cube root. So the cube root would be the same thing as the 1/3 power, right? So I'm going to take this, both of these 1/3, sorry, and move them to the front of their logs. So final answer here will be 1/3 log x minus 1/3 log y. Okay, and then for the last one, let's do like log base 3 of 3 over x to the 4th. Remember, these rules work the same no matter what the base is. So that doesn't affect your answer. We just need to make sure we're always writing log base 3 for this one. Okay, so I have log base 3 of 3, so I'm separating all the parts, and then minus log base 3 of x to the 4th. I'm subtracting because these were divided. So I have log base 3 of 3 minus, I'm going to move the exponent to the front and make that 4 log base 3 of x. And that is my expanded answer there. Okay, so as you can imagine, these can get, more and more complicated, but just remember, anything that's multiplied gets added. So like on this one, the 2 and the x are both added. Anything that's divided gets subtracted, and you will keep it straight. So if even you have a bunch of stuff on the top and a bunch of stuff on the bottom, anything in the numerator will come out being added or positive. Anything in the denominator will end up being negative. So now we're going to go the other way around. We're going to condense the log. So condense the logs. I'll just abbreviate there. So we're going to start with a bunch of separate logs. We're going to rewrite them together as one log. So using the properties. So A, I'm just going to do natural log 5 minus 2 natural log x. And I want to rewrite these as one log. Okay, before I can do that, I don't really want any coefficients in the front. So I'm going to go ahead and move this 2 back to the exponent. Okay, so I'm going to write this as natural log 5 minus natural log x squared. And now because it's subtracted, when I combine them together, I'm going to divide. So my final answer there will be natural log 5 over x squared. So kind of similar to this one, except I'm doing it the other direction. I'm starting with the expanded, and I'm condensing it back to one log. Okay, let's try a couple more. So what if we have like 3 natural log x plus 1/2 natural log y? Well, first thing I'm going to do is move these powers, or these coefficients back to the exponents. So I have natural log of x cubed plus the natural log of y to the 1/2 or radical y. You can write it either way. And so when I combine these together, since they're added, I'm going to multiply the x cubed times radical y. And that would be my final answer. Okay, so you combine it all in one log. Okay, what if I have something like this? Log base 2 of 7 minus log base 2 of 8 plus log base 2 of 4. So I have 3 terms now that I'm trying to combine. So the log base 2 of 7 is positive. The log base 2 of 8 is negative. Log base 2 of 4 is positive again. So when you combine these, anything that's positive, you're going to put in the numerator. Okay, so like the 7 and the 4. They were with a positive log, so they go to the numerator. Anything that's with a negative log, like this 8, goes in the denominator. So I can just kind of simplify that a little bit more. 7 times 4 is 28. So I have log base 2 of 28 over 8. I can reduce that. 28 over 8, let's see, 4 goes into both of those. So I think that's like 7 over 2. Yeah. I guess I could have reduced it at this step as well. So it's 7 over 2. Okay, let's try maybe one more of these. So I have natural log of x to the 5th minus 2 natural log of xy. That's kind of a weird one. So first of all, this squared, I'm moving it back over there. So I have natural log x to the 5th minus natural log of xy squared. So when I combine them together, the x to the 5th goes on the top and the xy squared goes on the bottom. Okay, well with this xy squared, I need to square the x and the y. So that'd be like x squared, y squared. So I can actually go ahead and reduce these x's and get a final answer of natural log x to the 3rd over y squared, because the x to the 5th and the x squared reduce to become the x to the 3rd. And there's our answer. Okay, so just to kind of recap, we learned these 3 properties, the product rule, quotient rule, and power rule. We use them to expand these sort of condensed, complicated logs into multiple, more simple logs. Or we can start with multiple logs and condense them down into one log using these properties. Okay, so we have one more property to learn today, and it is called the change of base formula. And a lot of this, if not all of it, really should be reviewed from Algebra 2. Obviously, I realize it's hard to remember all this, which is why we're going over it again, because logs and exponents are really important for calc. So you really need to be fluent with these and comfortable with these, not scared of these. So let's look at the change of base formula, and then we'll be done. Change of base formula. So it says for positive real numbers, a, b, and x, with a not equal to 1 and b not equal to 1, if you have the log base b of x, so say you have like log base 2 of x, and you want to change it to a different base. That's why this is called the change of base formula. Then you can do it this way. So let's say we want to change it to the base of a. Log base b of x is the same thing as the log base a of x over the log base a of b. Okay? So we've changed the base from a b to an a. And you may be asking, like, okay, why would I ever want to do that? And really the main reason why is for calculator purposes, because our calculator doesn't have log base 2. It has the common log, which is a base of 10, and it has natural log, which is a base of e. Excuse me. So for example, if you had the log base 2 of 7, and you wanted to rewrite that with a different base, you could write that as the log base 3 of 7 over the log base 3 of 2. So notice now I've changed these to have base 3. So to remember which goes on the top and which goes on the bottom, I just remember, this number that's lower goes on the bottom. Number that's higher goes on the top. So you could also write it like with the common log, base 10, log 7 over log 2. You could write it as a natural log 7 over natural log 2. And if you were to type these things in the calculator, log 7 over log 2, natural log 7 over natural log 2, I promise you would actually get the same answer. All of these things are equivalent. So for our last example, this would be example 3. We're going to rewrite using only natural logs, then only common logs. Natural log meaning base E, common log meaning base 10. So for A, I have the log base 2 of A plus C. So if I want to rewrite that with only natural logs, it'd be the natural log of A plus C over the natural log of 2. So I've rewritten this, that log base 2, with only natural logs. If I want to rewrite it with common logs, it'd be just log A plus C over log 2. Okay, and anytime you want to evaluate like a log with a base of 2 in the calculator, this is really the only way to do it, to change it to natural logs or to change it to common logs. Okay, and then for B, same thing. So if I have log base 4 of 2x, let's say, I want to rewrite this using only natural logs, then only common logs. So using only natural logs, it'd be natural log of 2x over natural log 4. So the 2x goes on the top, the 4 goes on the bottom. Using only common logs, it would be log 2x over log 4. And then let's just try one more, C. So I want you to evaluate with the calculator. Log base 3 of 7. So this would not be something you could do without a calculator, because remember the answer to a log is an exponent. And if I'm asking 3 to what power equals 7, like I have no idea, because 7 is not a power of 3, right? 3 to the first is 3, 3 squared is 9. So I guess I know it's somewhere between 1 and 2, but I don't know, 3 to what, decimal or fraction actually equals exactly 7. I have no idea. So this is where we would have to use a calculator, and we can't do log base 3 in the calculator that I'm aware of. You might be able to find a way, but I don't know how. But we do have a log button and we have a natural log button. And it turns out it doesn't matter which one you use, but in your calculator you can type in natural log 7 over natural log 3, and that would give you the right answer. Or type in log 7 over log 3. That would give you the same thing. So it doesn't matter if you use natural log or log. Either way will get you the correct answer. And I don't have a calculator right in front of me, so I actually don't know what that equals, but test it out on your own. Try it both ways. See that you get the same answer. Okay, so for your homework, you're going to be practicing using the product rule, quotient rule, and power rule to expand and condense logs, and then using the change of base formula to rewrite logs with not common bases, either with natural log or common log, and then to evaluate logs in the calculator. So you're going to do page 289, numbers 1 through 35, odd. So just like before, I know it's kind of a lot of problems, but I hope and think that they will go quickly once you get the hang of it, especially. All right, once again, I'll see you Thursday. Try to get all of this done by then. Circle or star the ones you have questions on, and I'll be happy to help you Thursday. All right, goodbye.